Welcome to the Diary of a Mainframe. We have Karl-Erik Stenfors with us. I'm very, very pleased to have this opportunity to record this session with him. Karl, welcome.
Thank you very much.
I
Honored to be your guest.
No, thank you very much. The honor is on this side of the recording table as well. Yeah, very pleased to be able to do this recording. I've known you for quite a long time, but that's just from an analog perspective. I've read some of your red books that you've wrote. I first met you in person, I think in Barcelona at the IBM Champion beverage moment. It was a pleasure that evening. I had tons of fun. I think you did too. So yeah, the Diary of a Mainframe, we discuss all things mainframe, but I'd say we stray away from raw technology. I'm very keen to hear your thoughts about your career, about advices you can give to the young mainframe people listening in on this show. What I've seen in my quick research, Karl, is you've started your career quite a while ago. Your first LinkedIn entry of a job is in a time frame when I wasn't even born yet, and I'm getting old too, so that was a long time ago. Is there anything you reminisce about from that era? I mean, my first question would be, how did you get roped into that line of work?
That is a good one, because this is a strange thing. I watched some time ago. I watched Laetitia Caro. I don't know if you ever watch her shows. She had a young student on, and he had done exactly what I did. I was trying to become a mechanical engineer, cars and gearboxes and what have you. And then at my university, they had this thing called the 360 Model 75. And I got to talk to these guys, and we used it, of course, a little bit. In the beginning, we used these very advanced HP calculators that you could program. But then we used this one. And I got to talk to the system programmers about the fact that they actually modified the operating system to do things for the students. And I said, wow. And that was done. I fell into the soup exactly like that. And I got employed by a company that did what we should do today. They hired me to actually go to school for a year, right? So they sent me to IT school, and at that IT school, we used that 360-75. So we learned assembler, Fortran, COBOL, what have you. But assembler got me because, mechanical engineer close to the machine, right? So I could see what happened. So I got, after the 1 year, I wanted to get into the sysproc department of the company that paid me, and everybody said, "Don't do that because the manager of that group is a real bastard." And we got to like each other a lot, and we are still in contact. He was my first mentor, a brilliant guy who is now gone into his 80s, but we talk from time to time. And he was the first one that kind of got me onto that track. But in those days, coding assembler was not like today, where everybody think, oh my, everybody did that, right? We did that all the time, and we modified the operating system a lot, both by, we could get most of the stuff in source code in those days, right? And if we couldn't, we used microfilm and SuperSat, right? You took a module, you want to add something, so you expanded that with the SuperSat. And then where you want to expand, you inserted a branch so that you could branch to what you want to do and then come back when you were done. But of course, for this was an MFT HASP thing. So HASP, was modified all the time. So we had, of course, the share tape, the world's first open source community was the share tape, where everybody and his brother submitted things onto so things like HASP to HASP, later known as NDIE, was already there. Shared spool, all of that stuff that DS2 has, we had that because we made that ourselves. So I was a very young sysproc, and what happened in those days was that a sysproc could write his own paycheck, right? So the 3-4 guys ahead of me that were much older and much more experienced left the company. And I was kind of tempted to do the same thing. And then this bastard of a manager came and told me, why don't you stay here? We'll pay you a little bit more. I said, well, I'll do that. But I was very young, so it was very, very heavy lifting, system generations, with card decks and what have you. We also, one of the very first CICS installations, we got a pre-release of CICS on the 2314 disk from the Hershey lab, because we had our own home-written TP monitor based on BTAM that we had written ourselves, where you had customers that would type during the day, put it onto a BSAM dataset, and then at the evening we would have a batch job to read that. So we introduced that into Kix as a transaction, which was very, very heavy lifting. And one of my first cock-ups was there, not mine, but the group, because we lost the data. But in those days, it was not the data was not lost. It was the VTOG. So what we did was we dumped the entire 2314, and then again with SuperSAT, we recreated the type 5 DSCBs, and bingo, here's the data back, no problems, right? Cool. So that is one of these things. It's more than 50 years ago, but I still remember, and I think this is probably part of what we call the culture. These guys, I was watching because I was so young, but these guys, they would bend over backwards, to fix this. And then when they had fixed it, they would bend over backwards again to avoid it happening again, right? And this is mainframe. This is how we work.
Yeah.
Look at how the technology and the hardware has developed. This is the thing that characterize the mainframe. If something goes wrong, first of all, we'll try to avoid it, which today's technology will do, right? Like if you try to do something stupid, the system will say, are you really sure you want to do this, right?
Yeah.
And if you eventually do that, everything is put in place to avoid it happening a second time, right?
Yeah, I couldn't agree more, Karl. Yeah, I hear a lot, even though my career started much later, I hear a lot of words that resonate with me. One of the big one is mentor.
Yes.
Because you're a smart cookie, but
well, I become one maybe.
We become
because I've had good mentors, and you asked about the young kids, and I said this is the first thing you need to do: get someone that has a little bit of gray hair, maybe, or at least some years mentoring, and then the next thing is get your hands dirty. You can't learn mainframe by reading a book. No. You can start reading a book, but you have to touch, and you have to make mistakes. Luckily today there are ways of mistakes being done offline, things like VM or things like emulators like the TK5, where you can actually screw up big time, and in a couple of minutes you're back in business, right? So this is the thing, you have to touch this thing. Yes, I agree. Theory is good, and theory is good to acquire, if you will, knowledge of things, but touching is absolutely the most important thing you can do, with a good mentor that looks over their shoulder, maybe not all the time, but at least from time to time, to put you straight. And the other thing is, be bold. Don't be shy. You might have ideas that this senior guy may not have heard about or thought about, and he may turn you down a couple of times, but don't give up. Just keep knocking. We have a very young woman on the net called Emma from Copenhagen. She's like that. She doesn't go away for anything. That's you know her. You probably also know Lucas from Germany. These are the kind of young people we want onto this one, because they have the drive and they are not afraid.
And they are, I would call that, they are overly curious and very adventurous, and that's the good thing. And I agree what you say. You need to have some. You need to develop your own battle scars as well. Right?
You can't be number one on all subjects, but at least you can be number one on some of them, right? At your selection.
I agree. So that really resonated with me, because I I think I see a lack of mentorship,
Yes,
if you put it all across the board, which is also, at least for me personally, it's not an easy feat to do as well, because it's not per se in everybody's mindset and in everybody's way of the way they are to be able to be a good mentor to new people on the platform.
no, that's true.
And then there's the question of time, because those most people with the little bit or more bits of gray hair are not the people in the workplace who've got nothing to do all day. They're usually in work.
Absolutely.
So yeah, that's a thing. But cool. So you were, for you, it was then, if we summarize, a active choice to go into the mainframe sphere.
Oh yes. But it was all by coincidence, if you will. But I've never looked back. I have to say that, because I had a very very rich career. So if I should summarize a little bit about that, being a sysprog took some years. I worked for a big Danish company that had a lot of customers. We were what you would call a service bureau, right? We were probably today you would call us a cloud provider, right? So we ran things for other people. Then that Danish company had a big branch in Nigeria, Lagos, Nigeria, Africa, which was importing anything you could imagine, all from needles to Volvo trucks and what have you. And they had a big application that they were running on what we call block time in those days. That meant that we basically rented the IBM site and traveled over there with 40,000 punch cards once a week under DOS VS, I should say. The problem in Nigeria at that time was power cuts. So you had written 39,000 cards and the power cut, right? Yeah. What do? You re-IPL and you reread the cards, right? There was no spooling system. Yeah, all over again. So one of the ideas was that we should try to change that into a local machine that we would buy and run. In those days, we had just taken a look at MVS. So I went down there with that in mind. And after a year, we had bought the machine. It was in Europe. And the day before we bought the machine, the Nigerian government introduced licensing, right? So the machine wouldn't come for another year. So I went back and because I couldn't stay, there was nothing I could do, right? Straight into a partner of that company in Norway. And that's where I really got my feet in it, because that was service bureau, 100%, not a lot of money. So we didn't buy a lot of stuff. Like we didn't buy RAG-F. We used the SAF interface, the RAG-F SVC and the control block. And we wrote our own in assembler code. We wrote our own security system from scratch.
Cool.
Fabulous. We also wrote a lot, again, very much based on the share tape. We took a lot of good interest there, but we did a lot of things ourselves, including what we would call a console processor that would display information to the operators in real time, tapes needed, etc., etc., etc. So that was a very, very rich experience. So much so that we actually sold that. We sold that solution to a Dutch company, Riot. I don't know if you ever heard about them. This was back in the 70s and the 80s.
R-A-T?
R-A-E-T, Riot, in Eindhoven, I think they were.
I think so too.
We also we sold it to a Swedish company, and we sold it to an English company. And the anecdote, the English, Holland, Sweden, Denmark, Norway, we walked in there over the weekend and did our own work. Coming to the UK was different. We were not allowed to touch the disk packs. We were not allowed to change paper in the printer. No. We were not allowed to do IPLs. So we would have to. So we went into the computer room and we did our stuff, and he said, "Please, Mr. Operator, can you please change that disk pack, or can you please put some paper in the printer?" Culture, right? And that's another thing that has struck me. That is the working culture of different countries, because I've worked a lot, in the US and the UK, in Norway, Denmark, France. So the working culture is important, and you have to respect it, because it's very, very, very different, right?
Yeah.
That was an aside. So what then happens is that we made our own company and we continued to develop. Then I got this nice phone call from Amdahl, Dean Amdahl, who was one of my heroes from the 360, were going to introduce the first partition-level mainframe in the 1984 timeframe, I think, the 5860 with MDF. So I joined Amdahl and worked on that and helped introduce that.
Cool.
From from Amdahl Norway. And then Norway is a small country. So people at IBM kind of knew that I'd been doing that. So I said, well, we are going to introduce something similar. Wouldn't you come and join us, please?
Join for it, yeah.
So sure. So I got into what was known then as the Field System Center, second level SE support. And then off to Poughkeepsie to write the Red Book on PIRSM, right? So I was then involved in this micro marketing between the MDF and the LPAR. What are the differences? Why is this one better than the other one? Why is red better than blue? And so on and so forth, right? So that was how I got into IBM. That was basically governed by that incident. Yeah. Then after that, I in IBM, we had things called assignments. So I went to a great one in London where I did early support programs for these very big water-cooled machines, big, very complicated projects, because we had to install machines that were not announced at a customer that couldn't talk about it, right? And pieces came from all over the world to actually be able to put the machine together, right?
Yeah.
And I did that for a few years, also introducing the small air-cooled 9121 that came about in that time. Then I was asked to come back to Norway to be part of the Lillehammer Olympics in 1994. So I got the opportunity of being together with another guy. We were responsible for capacity and performance for the Olympic system, right? And that was a strange project, right? You know the day and the hour when the project starts. You know the date and the hour when the project closes down. If IT is not ready, the games will go on, right?
Yeah.
And here's a good.
Yeah, I remember this from my youth. Maybe weren't that Olympic games where the scores and the timers on the TV screen had the IBM logo as well?
Oh yes. That was a big. Because IBM supplied all this stuff for nothing, right? The payback was the seconds that you had your logo on the screen.
Yeah.
So that was one of the. I had a very good friend of mine was responsible for assuring that IBM got the logo on the screen as much as possible. And here's what they did. For instance, the downhills, men's downhills. If you don't get the logo on the 4 or 5 first crossing the line, you'll never make TV in the US, right? Because the US, they don't watch the whole thing. They only watch the. So my colleague, and I think it was Psycho that owned the timing, sat down with the TV production and said, today we want those 5 with our logo on. So they had beforehand guess who would be the first 5 in the race. That was that's what my friend and colleague, he did that. That was the only thing he did during the whole games, assuring that IBM got the IBM logo when they crossed the line, right? Cool. So interesting. And then assignment. My first assignment we talked about. Now you usually don't get a second one, right? Because that's just how it is. But then I was lucky enough that my first line and second line manager in Norway were leaving, so I actually got a second assignment in '95 to go to Montpellier and do parallel sysplex. We had just introduced that, and I did that for a few years, and then I got back to Norway for a couple of years. But then I finally got hired by IBM France in 2000. And guess what? The mission that we had done early support program for in London now moved to Montpellier. So I went to my manager and said, I think I can do that. Yeah. So I did that from 2000 until I retired in 2011. And with that, I got into writing all the red books. I was part of what is called the C Atlas team. I don't know if you ever heard about it, but it was a small team that would manage connections between the lab and the customers. Nobody in between, talk to customers, what is coming, what do we think is important, and carry that back to the lab.
Yeah.
I was also a technical advocate for a very large company in Norway, which was even deeper relation, where you could actually go to that customer and talk about anything in the future. No bias, anything you would directly link to the lab.
Yeah.
So these things were towards the end of my career were extremely rewarding.
Yeah, I can imagine. You must have been at the forefront of a lot of innovation then.
Yes. Oh yes. All the time. From we talked about people, and one of the things I'd like to talk about is what happened in the early 90s. Where we had these big water-cooled machines, right, that ran on this. Now I have to look in my note. It ran on bipolar technology, which was very hot, very hot. So the chips were very small, right? And then they said, well, Nick D'Onofrio and Linda Sanford, two of my IBM heroes, went to Gerstner and said, we need to change the technology. We need to change technology. The problem was that technology was not very fast. That was CMOS. So the last bipolar machine, the processor was in the area of 60 to 65 MIPS. And the next one, the CMOS one, was about 12 to 15, right? So that was a very, very bold move. It's almost like the creation of the 360. It was a bet your business.
Yeah.
And what happened then, of course, was that it opened up enormous competition from the Japanese Hitachi Fujitsu, who continued the bipolar until what? Until another breakthrough, the copper chip, right? So when IBM, after having paused, came back and said, now we can attach copper on silicon, and that was in the 1998 timeframe. Then the bipolar machines would just fade away. They didn't have the muscle, technically, personal wise and money wise, to do that transition that IBM had done a few years earlier. And now you know the rest of the story about what happened. The machines got smaller, easier to install, faster and faster. And then, of course, the last one I'd like to talk about is when they redesigned the pipe of the processor. Because up until then, they were running in the area of 1.6, 1.8 gigahertz. Now, because they redesigned the pipe, they could now go to 5.2, 5.3 gigahertz, which was another one of these great things that happened that has kind of been left behind. Is it important? Well, it depends. If you're running single thread applications like batch, this is excellent. Like certain parts of kicks, this is excellent. For the most important part, of course, is what you would call the throughput. But with a 5.2 gigahertz chip and 200 processors under the covers, you have a pretty mean machine in front of you, right?
Yeah.
So I think those are some of the things. Of course, the 360 in itself was a very, very big thing, very, very big thing, where they basically bet the business. They thought they would spend $1 billion. They spent $5 billion, mostly on software, right?
Yeah.
Mostly on software. Very interesting. Fred Brooks, I don't know if you heard about this, Dr. Fred Brooks, who was an ardent opponent of doing the 360. He said, we are not going to do this. I cannot do this, because he had this new 8000 coming out. You know what they did? They said, you're the project manager for the 360, right? Very, very clever. Very clever. Very clever. And he excused himself. There was a recording from the beginning of the 2000s where he was presenting at the Computer History Museum in California. And he said he wanted to excuse himself for JCL because he had been doing that. Very, very, because JCL, now we are talking about anything. JCL was not considered a programming language. It was just 3 control cards: job, execute, DD. Very, very simple. And all the intricacies were hidden in the parameters. That's where you really could screw up, right? No, so those are a couple of those people that I met. Then what happens is that the country where I spent most time in my career is in Norway. So I had a very nice retirement package. And then all of a sudden they implemented something called retirement on demand. When I was 64 years old, I said, I'll go. Thank you. Bye-bye. And I thought, well, IT is over. Now it's time for doing something else. So I went to study political science at the University of Montpellier. And then phone rings. Phone rings in my career has always been that. I never applied for a job except for the first one. All the other ones, phone rings. Saturday night, Sunday morning, phone rings here, and a president of a private university in Montpellier says, can't you come and teach? I said, well, I've been teaching all my life, but I've never been teaching academics. And she said, oh, you can do that. Well, you have to note people. I hate that because I like the work people do, right? But now I have to note my students.
Yeah.
Oh, I hate that. That's terrible. That's terrible.
Yeah, you mean grading them, giving them
grading them.
Yes.
Terrible. It's terrible. But now I've been doing it for 9 years, so I'm getting there. I'm probably too soft. So what happens is that she said, can't you come and teach? And what should I teach? She said, can't you teach Linux? And I kind of knew Linux because I was on the very early when it came onto the mainframe, end of the 90s, where we did some classes where we tried the word to teach people Linux on the mainframe. So sure, I can do that. So I do that. And then we were talking to IBM, why don't we do a mainframe class? And we were almost there. And then in the last moment, they said, no, we want to do something else.
Yeah.
So I said, well,
university.
Yeah, I'll fix that. So I teach now 4 or 5 classes. None of them are mainframe classes, but I use mainframe in all of them. Linux 1 in Marist College. A lot of people don't know that. You can get a free virtual machine at Marist College for 120 days. They give you 2 processors on a C16, 4,000 gigabytes of memory, and 4 gigabytes of memory and 50 gigabytes of disk space. You can do anything. They have all the Linux distributions, anything you have. My students, that I teach them Linux on their PC, and then I said, now over to something completely different. And it's the same interface. So you can see you have Linux on their machine, and then Linux 1 on the side. The interface is exactly the same commands, same distribution, but the environment is different, right? That's one of the things. Then of course, and this is the easy part. Now the next one, a couple of years ago, one of these universities came to me and said, can't you teach assembler? And I said, which assembler? And the school said, you have heard this, you decide. And I said, that took a microsecond to decide which one, right? This was a little bit more difficult because to get access to the Marist College COS side, you have to be part of the IBM Academic Initiative. And I got that. So now I'm teaching assembler using the Marist College COS system. So all of my students get introduced to that. And then, of course, some of them don't have good internet connections. So I gave them the TK5. I don't. It's from Holland actually. A guy took the TK 1, 2, 3, 4 and made the TK5. This is a zip file that you unzip. You take one command, you have MBS up and running, and then 3270 on the side.
That's the one that runs MVS 3.8J, right? The community.
Yes. Yeah. Because that was the last public domain that you could take.
Yeah.
I know there are some people that do other things that we don't get into, but I do that.
No,
we don't want to talk about that.
No, I don't know what you mean. Links in the comments, huh?
Yeah. Okay. I see. So when it's of course not the COS of today. It's not. But if you are a young student or a young professional that want to pick up the concept, it's all about the concept. What is assembler language and what is its position? You can use that. It's excellent. It's absolutely excellent, and it's easy to use. There's a great manual. You have to do a little bit of JCL.
Yeah,
that's the way it is. My students like that a lot. They think it's because it's all portable, right? I think there's an Android version you can run on your telephone actually, if you want to. It's difficult to see a 3270 screen on a smartphone, but can be done. The only thing is that on Marist I can use Zoe. I can't do that on and this is another one of these brand new open source things that happen. The Open Mainframe project. Zoe is absolutely fantastic. It's really, really, really good. I went to another conference a couple of days ago, and there was a very, very big French customer that talked about how they are using Zoe to get young talent onto the machine, because it's an environment that they're used to, that it kind of looks like what they come from, right? But at the same time, I have some of my students, they actually like the ISPF.
Yeah.
Once they got into the PF keys and all of this thing that we used to do, you know, with our brains completely coupled out, because it was just in the fingers, right?
Yeah.
So I think that is excellent.
Your assembly classes at the university, just out of eager curiosity, I would say, what are the kind of assessments you let those students do? What kind of, because I mean, there's probably a whole, you know, half semester on just being able to do a hello world, but then you need to make them do some real programming, right? And is that then linked to some stuff from your past or the future enterprise stuff? Or
well, you're good with the hello world, because that's the first program they do. And they can basically do that without anything else, just write to operator, hello world, right? But the name of the class is actually processor design and assembler programming. So I spent a bit of a time up front talking about how did assembler come about, why did it come about, and then moving into what is its position today, because there are people who are looking for assembler programmers even today. So I talk a little bit about it. If you want full control, if you have something that's running a lot of time, it's running all the time, assembler subroutines called from COBOL or from Java or from anything, right? So I had to talk about what we know as the linkage convention. How do you start a program and how do you end a program so that it can be called and it can call other things, right?
Yeah, in the ecosystem.
So their first coding is housekeeping, store multiple, you know, blah, 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 read WTO, and then reload multiple and return. So there's one piece of code. And then I show them that in Python, you know, write to operator. In Python is print, hello world, done, right? Done. So they get to this idea that when you code assembler, there's a one-to-one relationship between what you code and what the machine does, right? Except when you use a macro, because it expands a little bit. And then I also try to show them a COBOL example where you can actually get the object deck from the COBOL compile. And there you have hex 90, store multiple. Yeah. Absolutely. So I show them, here you see, this is exactly what you've been doing. These 4 or 5 instructions up front make sure that this COBOL program can be called by someone, and this COBOL program can call someone, right?
Yeah.
So this is a 27-hour class, and you can't teach them coding assembler in 27 hours. But you can point them, and I use some wonderful stuff. I don't know, you probably know the Ehrman, the George Ehrman mainframe assembler book. It's an IBM guy, and with that comes also examples and a set of charts where you can actually self-study, if you will. It's absolutely excellent. There's also Clarence German, who has written Coding 360, where he also talks about other things. These 2 basic, very, very basic books is what I kind of put in as a background. So my class is basically based on Ehrman's book, but I can't go very far, you know. I can talk a little bit about different things here, right? So that's what I've been doing, and I've just received yesterday for my next year. I'll have about 120 hours of teaching starting late September from B1, from Bachelor 1 up to Bachelor 3. So busy hours. Now I'm trying to kind of update my stuff.
Yeah, I can imagine. So yeah, but so teaching is still your I'd say one of your favorite post-retirement activities.
Absolutely.
And
Absolutely.
writing books, I think, and or consuming them come to
Yes.
mind. You were talking about your Linux on the mainframe early experiences. I mean, I think you were at the forefront of it back in the early 90s. And I
Late
do.
late 90s, we got to touch it. I was lucky enough to have a brilliant guy working with me, Jack Poirot, who was deep technical. You could ask him anything on anything. He had been working with IBM for many years, building all kinds of things, and he actually drove this. So I traveled with him to all imaginable and non-imaginable countries where we actually had access to our machine back in Montpellier, where we would be running COS on one side and Linux on the other side. And in those days, we used something called connectors. I think today they're called APIs. So we taught people how to, and this was Java, right? So we basically ran this Eclipse that we had at the time, where we would go to the COS and take the COBOL copybook or the NQ information or the IMS information, and then using Eclipse create a Java program that would then use the JDBC connectors to go and extract information from a DB2 database, or execute a KICS transaction, or send something into MQ or IMS. So we did that for a number of years. Linux wildfires, they were called. So that taught me a lot, especially because of Jack Poirot, who was another kind of mentor. But we were about the same age, so it was not like, senior to junior. It was more senior to senior, but opened a lot of eyes. So and of course I could then profit from that when they asked me to come and teach, right?
Yeah, can imagine.
Because I've been doing that.
Have somewhere on the shelf here a red book with your name on it as well, and I think it's Linux for the Z9. So that must have been early 2000s, I think.
Yeah, we wrote a red book on what we just talked about. We wrote a red book on the fact that when you have Linux and COS on the same machine, you can earn a lot in terms of also of throughput, because we were using internal connections between the two, not cables on the outside. So we did that. We talked a little bit about people probably don't do it anymore, but at that time you could actually have RACF on COS secure your Linux environment, or you could have an LDAP server on COS securing your Linux environment. So we built something on that. Also, we did some WebSphere on COS that I was involved in, but after that it was COS and hardware early support programs, right?
And then there's this other book, because you are second in a big line of people, big names I still want to talk to. And that is a very amazing book and I think the story is so cool it can be repeated a billion times. The world was down with the big pandemic. Things were closing down and stuff wasn't happening anymore. But then, I'll use my own words, a couple of old ones get together and write a book, which I think is amazing. And I think the amazing thing is that you've wrote that all in a remote collaborative fashion, which
absolutely we had never met before. I finally met one of them, Reg Harbeck. I met him in Barcelona in January this year. So the other guys I haven't met. Let me show you the book. I don't know if you can actually.
Yeah, I hope that. Yeah, that shows. Yeah, the and that's used in. I think Cameron uses that in his classes as well.
Yes, absolutely. He uses that because he's a big guy. He's we are standing on his shoulders. I mean, the other guys, David Boyce is extremely important guy. He's in a company called Sign in Nomine, and he was very key with one of his collaborators when Linux came to the mainframe. This guy is a working dictionary and knowledge of anything IT. You can ask him anything. Reg Harbeck, you of course know, who runs a company in Canada on mainframe consultancies, and he writes a lot. He's on Tech Channel. I don't know if you have talked to him yet, but I mean, these three other guys, you should get them on.
No, he is. So, Reg, be warned. I am going to be hounding you soon.
And take Cameron also. David, I'm not sure he'll do it, but you can try. You can try. He's extremely knowledgeable, and here's the wonderful thing. Since we wrote the book, every Saturday we talk, the four of us.
Yeah.
We talk every Saturday. We talk about anything you can imagine. We talk about the mainframe, of course, but we also talk about cooking and wine and life and what have you, right? So this is a very, very interesting partnership that we actually. The thing that happens is that Cameron was contacted by the editor that said, "Can't you write a red book? Can't you write a textbook to use for high schools and universities in the US?" And he basically said, "I can't do it myself, but I'll find a few people who can." And he asked on LinkedIn, and we just said, "Yes, sure, we can do that." Cool. I was a little bit afraid because I'm the only non-English speaker. So we talked about writing styles, and I said, I've been writing red books for a long time. And they said, well, this is the style that we wanted to be written in. So I felt very comfortable. And so what happens here is that we cut it up in different pieces, and each of us wrote something, and we wrote something ourselves, or we wrote something inside of the other guy's chapter. So it was a real collaboration effort. And cool. Luckily enough, we got IBM to kind of put their stamp on it, right? Saying that what we are doing is great. They let us use their there's a lot of copyright on images and photos, and you can just take a look at the front page. You see everything is on there, right? And the theme here, I think we talked about it earlier, people and technology, right? That's what the mainframe is all about, people, technology, and in the people, there's this mainframe culture, if you will, that is a very important part of mainframe thing, because this thing cannot stop. This thing cannot stop. That's the way it is, and that puts a enormous amount of responsibility for the people who run this system, and of course on the people who construct it, on IBM, on some other software vendors. I was on a very, very good seminar this week with Broadcom here in France. Very, very a big company that puts a lot of money into that. You know, Hock, who is the president, has put so much money into this environment to run the world, because that's what it is. You run the world. You run the world. If I ask this is interesting. I ask my students when we've been talking with, I say, what do you think would happen if all the mainframes in the world stops? So there's complete silence in the room, and I say, you're absolutely right. Nothing would happen, right? No travel, no bank, no assurance, no nothing, right? It can't go. It can't stop. It can't go away. And this is one of the things Cameron says is very good about. You know, because he's the one who teaches a lot. My classes are very, very small, but Cameron, he has these big classes, and he runs what he calls boot camps, 12-week COBOL boot camp. Yeah, absolutely fabulous. And there he calls in other people like Jeffrey Decker. You may have heard about him. An excellent guy. He's another one of these guys that can't stop. Cool. Right? Yeah, I was lucky enough to be invited into his last boot camp, where I took the introduction of my assembler class. I took to the students, and some of them actually came back and said, "Can't we talk more later?" And I've had one or two of them talking to me later about this thing, you know, the mainframe.
In the mainframe thing.
Yeah. Because there's one thing that also buggers me a little bit, just a little bit. It's this thing about Zoe and other things that makes it easy to manage for new people. But I still think you have to have somebody in each installation that can take on his white coat and his thinking cap and get the screwdriver out and then touch everything that's behind there. I can't imagine a world without that. I may be wrong. I may be wrong. But what I
Then
think,
we're both wrong, Carl. I think because I mean, at some point in time, Zoe will not run for whatever reason, and
for
then what?
whatever, why, absolutely.
Then you still need to. Yeah, I totally agree. No, you said a magical word that's always a laugh here. You said who run the world? Mainframes, right? There's this song we don't do. Maybe we link the song. I think it's Beyonce who goes, "Who runs the world? Girls." I don't know if you know that.
Yeah, but
And
mainframe and girls is, well,
my daughter used to sing that a lot, and then
how
she'd go,
goes?
"Who run the world?" And Daddy would say, "Mainframes." And she'd go, "No,
Well,
Daddy, girls." I'm like,
well,
"Well,
yeah, right.
mainframe would be a
You're
good."
right. No, I think so. You know, I'm an old hand. I was a real systems programmer. Where
Yeah.
those days we knew everything. We knew everything that was in there. Let me give one example of that. When I came to Lillehammer to the Olympic Games, uh, the main system, there were four families of systems. The important one, of course, was the result, right? And that had to run all the time. But then we also had a nice little one where when people came to get their badges, that was basically a Kix transaction with a photo. And that Kix transaction, unfortunately, was designed to kick off a batch job, right? And that batch job had to run because this guy was in the queue waiting for his badge.
For his badge, yeah.
Yeah. So we used something called, what was the name of that? There was a way you could record from earlier games and then replay that. I don't remember that it was an IBM product. So what we did was that we set that one up, and then we used the system resources manager to find out how much resource would this Kix job use to be done. And then we time sliced this this batch job into the result system, so that the batch job would just take exactly what he needed, using what we call the first period of SRM, and go back. And we could do that because it cost nothing. It was just a matter of getting it in there, right? Very, very interesting. I have my notes somewhere where we did that several times to figure out how much, because in those days you had to give resources, not in terms of response time. This was really thinking hat thing. You had to use what was it, MSUs and what have you, so that the Kix job batch job would just get enough resources to get in there and get out again without bothering the downhills.
You were preemptively calculating the resource consumption of printing that badge and all the stuff required, and then you come out, oh, this is going to be 14,000 instructions. So we
absolutely at that level.
Now.
Yes.
Yeah.
At that level, and it worked wonders. You know, you could say, well, when the game started, everybody has arrived. No, everybody has not arrived, because there are some of the competitors, they don't arrive the day one, they arrive day 5 or day 7 or day 8, depending on their schedule, right? So this had to run all the time, but at the same time, we still had to have the timing when the guy crossed the line in downhills. We had to have the timing on the split second he was there, of course, with the IBM logo and the Sony logo on the Psycho logo on the side, right?
Yeah.
So and these things, I think, could happen anywhere, even today. And here people have to come and say, how do we fix this? How can we? Because this was one particular job. It was not a bunch of things. It was one job that ran all the time, and it didn't use a lot of resources. It was just a matter of, you could prioritize it in a way. You could prioritize it in a way that it would just get a little slice of the time necessary to do this, right?
Yeah. Cool. So cool. You'd almost think, because that Lillehammer Olympics is a long, long time ago.
30 years ago. 30 years ago.
How cool it would be if IBM did something like that with a global event like the Olympics, or I don't know, a World Champions of football, or that would be a good commercial for the mainframe, wouldn't it?
It would, and you know, they did this up to 1990, up to 2000. The games in 2000 were the last one, because the Olympic Committee wanted to cut the IT into pieces, and IBM said, "There's no way we can accept that, because you know what? we have a history. We've done Olympic since 1960. If something goes wrong, we'll be blamed, even if it's not our fault, right?
Yeah.
We had an example of that in Atlanta, Summer Games in Atlanta. Something went wrong. IBM got blamed. It was a contractor on some transmission modules that had done the thing, right? So IBM said, if we can't control it end to end, we are not going to do it anymore.
Oh, I can imagine. Well, dear IBM people listening in, think of something cool to do globally with mainframes, right?
That would be great.
That would be really, and if you need a techie, you can always call Karl-Erik and he'll come help you out an afternoon.
Sure.
Mm-hmm.
Here's another anecdote for you. This I hardly could not believe it. I was on this meeting with Broadcom a couple of days ago, right? And this was in Paris, and then all of a sudden afterwards there was a little thing where we had a wine and stuff, and the guy comes up and said, "Well, we actually know each other." I didn't recognize him. This was very, very bad. He was the French participant. I remember him as such. He was the French CICS specialist on the Lillehammer team 30 years ago. We haven't seen each other since then. So now we are in contact, right?
Yeah.
He works for DXC today. And incidentally, I saw today a speculation that IBM would buy DXC. I don't know if it's true or not, but there was speculation today.
Cool.
So see, I follow a little bit what's going on in the world here, right?
Very, very good. I could continue talking and recording these podcasts with you for hours and hours, Karl. But looking at our time, I think we have a good hour and a bit on the clock. We've looked through some questionnaires and what you call them, not questionnaires, but multiple choice, questionnaires on proper podcast lengths. Now, all the answers vary, but on average, people tend to like short form more. That's not me personally. I like 2 hours worth of podcast to listen to myself. But
well, that's good.
Before
we stop, I have one thing that I should tell you. In Barcelona, can I do this? In Barcelona, I talked to Tina Tarquinio, who is now owner of the System C. I don't know if you followed that, but when the C16 was announced, the processor was actually announced before the product. It was announced in August. Now what happens this year? The processor for the next machine will be announced in August at Hot Chips in California. At least that's what Tina said. She said, we will do that again. And this will be the chip that will power the next machine that will probably come maybe next year sometime. I don't know. But that is interesting because that's another up level of the technology in terms of size. So they have minimized once more the what they call the gate. I think they're down to 5 nanometers or 3 nanometers, where the C16 is 7, right? Yeah. And you know the C16 chips has 22 billion transistors on it.
Yeah,
what will the next? How much will the next one have, right?
Yeah. Well, if they're nearly halving the distance between the lanes, you might think it could nearly be well, not double, but when you look at the geometry, it will be at least 30% more transistors.
Absolutely.
So
absolutely. And maintaining the clock speed, of course. World's fastest processor chip, right?
Yeah, probably with more onboard AI capabilities and stuff.
I think that's a guess that I would support. Absolutely. Yeah. When you hear them talking about the AI on the mainframe, that would be a very natural extension to that. Sure.
Yeah, I think so too. Karl, I think I will be asking you to rejoin our lovely podcast again for another episode, because there are a billion subjects that I still want to cover with you.
Anytime.
As stated, and I think these, like you said, right? I think by doing this recording, by having your anecdotes and the way you look at things and the stuff you experienced and the stuff that you broke and the way it helped you grow as in your career and as a person, I think that's almost like the real thing for a lot of people, to have a bit of Karl mentoring for them.
I have another. This is terrible. I have another one, even worse. You know, when DS2 came around, DS2 was introduced as what we call a subsystem in TOS, right? So the idea was, well, we can have a secondary DS2 as a subsystem, right? And we use that to test. And this is early. This is late night. It's very late night. Batch oriented. All the batch jobs are done, and so on and so forth. And a colleague of mine went in there to do secondary DS, except that we forgot to change the DD card with the spool disk, right? So when we started up secondary DS2, specify parameters for DS2, cold comma format, right?
Yeah, so
all of night's production gone. This was because that could not be fixed. That
No.
was because the new checkpoint was written and the rest of the stuff was gone. Terrible, terrible, terrible. But you learn from that, right? You learn from that.
Yeah, you do. I'll share my biggest lesson as a hair on fire story closure of this podcast. I was young. I was 21 and a bit, I think, 22, on my systems programmer job, and I was officially the storage manager. So I was doing the enterprise storage subsystem, the ESS now it's the DS8K, but the RMMs. But that was new, and we had older, I think it was even Ramak virtual arrays that had to be migrated to this new storage box. So my mentors, Pete Louis, thanks again, gave me the task of coming up with a plan to migrate all that stuff from that box to that box. I'm like, oh, okay. We had some
piece of cake, right? Piece of cake.
We had very lovely software for that procedure. I don't know what it was called, but it was some yada copy software, which could in-flight copy control units from one system to the other, and you wouldn't have to have a downtime moment.
Sounds good.
FDR copy, FRD copy, something like that.
FDR, we had that. We had that as well, yeah.
Which worked brilliantly, but you could not use that for everything, right? So at the end, due to normal new allocations going there, old allocations disappearing from the old hardware, we had nearly everything done, and you had this last bit. And the last bit was the things like IPL volumes, JES2 procedure.
All so things, not important things, right?
The non-important things. So I made the plan, and I said, well, for the IPL volumes, we need to make them ready, but we can only do that during IPL time. We IPL from the different packs, and yeah, that was all good. And the JES2 procedure library volumes, I am just gonna RDRD SSU them and restore them on the new volume, and life is good. And my mentor said, well, Henry, you gave this some good thought. Execute. Cool. So I get to work, and we were working in this semi-open office, cubicles with 4. And I pressed the button on, submitting the job that would dump the JES2 procedure volume, restore it on the other volume, and take that volume offline. As planned. And all around me, it goes, what? Huh? I can't log on. System's down. What? That's how I learned you can't do that runtime. So I remember going back to my mentors going, why did you let me break this? You've read my plan. It was in the plan, and you said it was good. Like, yeah, but this way you've learned.
So that's a tough one.
Which was a very hard lesson, but that for me was and not just on that technical bit, but the extreme lesson of think again, validate with someone else, and sometimes maybe get a second opinion, because it's so, I'm not saying the mainframe is so easily broke, but like we've said, right, who runs the world? Girls and mainframes.
And mainframes, yes.
If it goes down, it's a slightly bigger problem than the print server not working for an hour.
Absolutely. I agree.
Cool. I thank you very, very much, Karl. We will, of course, let you know when this airs out. I hope we get some good reviews, and I will definitely try and plan something again with you for our diary.
Thank you. Would love to. Thank you so much for having me. It was a pleasure.
Likewise, Karl, likewise. We shall meet again in the person, I hope, soon, and then we'll do a bit of wine and things again. I'm looking forward.
That was a very good session, you know.
Mm-hmm. Yeah, let's hope the lovely IBM girls will organize another good meetup for our IBM champions in Europe. So, Libby, get something organized, huh?
Yes, Libby,
cool.
I support that.
Cool.
Come to Paris or to Montpellier, and we'll have a good time.
Yeah, Montpellier sounds nice.
Oh yeah, we have a good, nice, very big conference center. So
yeah, sounds good.
Open invitation.
Cool. Karl, I will end this recording here. Thank you very much, and we will definitely be in touch. So thank you very much.